Welcome, everybody. Welcome to Mastering Kubernetes Efficiency. We're going to be talking about proven strategies for DevOps and FinOps leaders today. I'm going to give you guys a chance to get on. So welcome for those who are joining. Great to have you here. We can see the participants joining now, so thank you. All right. They're still coming on. All right, so I am very excited to be here. I'm very excited to be with two of my favorite personalities, Dieter Matson and Andy Suderman. Both of these guys are my heroes in the FinOps space, okay? These guys have years and years of experience in this space, lots of scars, battle scars and wounds to prove it. And so we're going to have a really interesting talk today about the whole space around Kubernetes efficiency, lack of efficiency. We're going to start out talking a little bit about the history of how we got here. And then we're going to be talking about what we're seeing in the industry, what are the issues today, what are some techniques that we can use to tackle some of the challenges. But I'd like to introduce Dieter. Dieter is from Roku. Dieter is also an ambassador of the FinOps X Foundation. Dieter's got 10 years plus of working with the most amazing companies focusing on FinOps and cloud cost optimization with, companies like Google and Netflix and Intuit and currently at Roku. So welcome, Dieter. Thank you for being here.
Thank you for having me. I appreciate it.
And Andy, Andy's the CTO of Fairwinds, and Andy has had some incredible experiences as well. Working with Kubernetes in the very, very early days. You were actually, I believe, one of the founding members or early members of the CNCF way back, back in time. So we're gonna go there and talk a little bit about what it was like in those days. So we're very excited to have you, Andy, and I'm looking forward to learning something today.
Thanks. It's good to be here.
Okay, well, with that, Andy, I'm going to actually get you to talk a little bit about the history of cloud, Kubernetes. What were the issues around the early days around cost and cost management, if any, and if not, why not? And how did we get to where we are today? I'd love to hear that story.
Yeah, that's a really interesting question. So going back 8 years to when Fairwinds started running Kubernetes for our customers, it was brand new. Kubernetes is only 10 years old at this point. So at that point, it had only been 2 years old. We were running Kubernetes, I think 1.4 in the early days. And, really most of the problems that we were facing were just getting it running, right? Keeping our workloads up and running, getting folks used to it, getting folks comfortable with the cloud. Because even, that was kind of a new concept still to a lot of folks. I mean, it wasn't new, but a lot of our customers were coming from on-prem or traditional backgrounds. And so really most of our struggles were just, let's get it running. And the other side of that was all of our customers in those days were small startups, because the only people willing to jump into a brand new 2-year-old infrastructure technology are small companies or really, really innovative companies. And there's not a lot of large companies doing that. And these small startups had really big budgets back then. So they were just kind of, printing VC money or burning VC money, as it were, in those days. And so really cost never even entered the realm of what we were doing. Nobody even asked us about cost. It was, why does my pod crash? Not how much is this pod costing me? And, I kind of got involved into it in the early days because we were asking our customers to set resource requests and limits on their pods because that was a reliability problem. We were trying to get them to, help the scheduler do its job better and help pods get enough resources and not have noisy neighbor problems. And that's how we sort of entered into this world of efficiency. It wasn't from the cost angle, it was from the reliability angle. It turns out over the years, that's just become, we're looking at it from the other side of that coin, which is that's how you also control cost. And so over the last few years, as budgets have been squeezed, money isn't quite as free as it used to be, folks are really focused in on cost, and we're also realizing just how expensive the cloud is when you misuse it. It's really shifted to that side of the equation, but at the end of the day, the tactics are all the same, which I think is really interesting.
Right. So in the whole CNCF was created to provide a community around cloud and adoption and so on. But then suddenly this cost issue comes up and the FinOps Foundation comes along. Maybe Dita, you can talk about how that became a thing that required a community of support, and you can talk a little bit about that for us.
Yeah, absolutely. I mean, the FinOps Foundation really has their roots from the customer advisory board meetings that Cloudability had on a quarterly basis, right? Where the practitioners expressed that there is a need for cost optimization in the cloud, and there was really no set guidelines or rules or run books on how to do this. So there was no documentation. It was not repeatable, right? People were just doing whatever surfaced and focusing on that, right? Instead of having sort of like a programmatic approach to cost optimization, right? And then I believe it was in February 2019, this is where the FinOps Foundation was founded. And then later, it was became part of the Linux Foundation in June 2020. So just like maybe a year and a half or something like that later, right? They became part of the Linux Foundation. The FinOps Foundation was always a nonprofit. This is how they started, right? And then it was just advantageous to merge with a broader audience, right? And I believe the last count was that the FinOps Foundation has over 20,000 members. So that is, quite impressive. I remember when there was just like, a handful of us talking, right? And now it's a huge community. And really, cost optimization in the cloud, we really only have two levers, right? Rate and usage optimization. And so the FinOps framework is teaching us on how to do these. It's documented, right? And it helps us to do this repeatable and also measure internally and externally how each organization performs.
Yeah, that's awesome. I actually did the practitioner certification, and I found it I found it extremely interesting from the point of view of how much of it is related to organizational structure, organizational culture. Yes, there's the technology part of it, but without the structure, the culture, the mindset, it sort of falls apart. So I just found that it's obvious when you look at it and think about it, but it was very striking for me just how important that piece of it is as well.
That's true. Yeah.
Very good. So I'm going to, for the audience, I'm going to launch a little poll here. We're all curious to know how efficient your environments are. So let me launch this poll here. And we have a guess for what we think is going to be the average, but we'd love to see what actually comes out as well. While you guys are answering that poll, we can continue on here. So let's talk about slightly changing gears towards the current efficiency issues. So Andy, you talked about resource pods, limits, setting them appropriately. So that is one part of it, but there's also a lot of inherent inefficiencies within a pod and within the actual code as well. I'd be interested just to get your sense of where you see the efficiency issues?
I mean, frankly, we're so far off on where we're setting our resource requests and limits that most folks aren't even at the point of optimizing their code base, right? We're seeing efficiency numbers in the, 5-10% at best for CPU and or memory usage. And that's simply because people don't know how many resources their pods need when they deploy them into the cluster, and then they never go back and change it. I feel like I've been like beating this drum of resource requests and limits for like 8 years now, and really not much has changed. We have more tools for visualizing, we have more tools for looking at it. We've written some tools, and so we kind of know these numbers now. We see them, but actually making those changes is really hard for folks. And I think what we're seeing now, well, we'll get into this probably more a little bit, but like automating that is going to be the next big thing. So.
Right, very good. And what are your thoughts, Dieter? How would you respond to that?
For me, Kubernetes is sort of like a venue, or containerizing your workloads, right? It's a venue to get off virtual machines, right? When you think about that, like 95% of all IT is still in data centers, right? And in data centers, the hardware is procured, and then it is amortized over a 3, 4, or 5-year period, right? So the hardware is intentionally purchased a little bit larger so that the workloads can grow into it, right? In the cloud, now, if you have organizations that migrate from on-prem into the cloud, right, they typically use t-shirt sizes, like small, medium, large, right? And my recommendation is also to get into the cloud as quickly as possible so that we can start optimizing, right? Because optimizing in the data center is also possible, but not as easy in the cloud, right? And the core benefit of the cloud, there's a couple, right? But one of the core benefits of the cloud is that it is elastic, right? If you stop using something, you also stop incurring a cost, and that is not true in the data center, right? The thing is running 24/7, whether you use it or not, right? And now, once you are and there's other like globalization, right? The cloud is typically a global construct, right? So if you need to go to like Brazil or South Korea, that's very possible, right? But it has not much to do with optimization, right? Then the workloads are running on virtual machines in the cloud, right? And some organizations treat the cloud just like a data center, right? And that's not how you do it. This is not how you do cloud, right? You want to be as elastic as possible, right? So if a workload is not needed, maybe you can put it on a schedule, turn it off after business hours, turn it back on when business hours start, those kind of things, right? But the virtual machines, in my view, are still legacy constructs, right? To help us migrate from on-prem into the cloud, and for legacy services that just are statically provisioned and cannot scale, right? And the sort of like the gateway to efficiency is containerization, right? Where you can take those workloads and now dynamically size them as necessary, right? Now, Andy probably has some good stories on why Kubernetes needs to be optimized as well, right? But it has to be optimized. You're not done when you move into a containerized environment, right? There is still lots of optimizations possible and necessary. And maybe this is what we're going to talk about today.
Yeah, awesome. That's great. So I'm just going to end the poll here. We've stopped getting results. So I'm just going to share the results. I don't know if everyone can see that, but what we have here is that 45% of you are suggesting that 10% of your dollar spend is on Kubernetes. 10 to 50% is 36% of you. 50 to 75%, there's some high EKS or Kubernetes use rather, 9%, and greater than 75%, 9%. Andy, how does any of this shock you, or is this what you were expecting to see?
I mean, it depends on the size of company that folks are working at, but I think this is pretty typical across the industry. I think a lot of the companies that are using Kubernetes are utilizing it for, some, small to medium percentage of their workloads. They haven't moved everything over yet. Legacy apps are much harder to move into the cloud, into containers, and into Kubernetes. That's 3 different migrations you have to do all at once for a legacy application. So it's a slow process for a lot of folks. So this doesn't surprise me at all.
Right. And then the second question, which is, are you using tools to optimize your Kubernetes spend? And a little over half is yes, 9% planning to, and 36% no. So that's really interesting. Are you surprised with the size of the no?
I'm not. I think a year ago, a year and a half ago, I would have been surprised at the number of yeses here. But that's definitely shifting more and more. So I think this is also in alignment with me. I don't know, Dieter, you're with the FinOps Foundation. You probably talk to a lot more folks using optimization tools than I do. So what does that look like for you?
Yeah, I mean, typically the people that I talk to, right, they are maybe more advanced. When you look at like at a crawl, walk, run, right? I typically talk more with the walkers and the runners, and they of course, we exchange, hey, what are you using for this? Which tool, right? We are using this tool. It has those problems. Did you encounter that as well, right? So yeah, those conversations happen. The 55% is still a little bit high. That means that there's awareness around Kubernetes optimization, but it also tells me that the 36% that are not using tools to optimize, and by tools, I don't talk about things like kube cost or something like that, right? I'm talking about like actual tools that dynamically adjust things in the containerized environment, right? And so it means that 36% are not doing anything, which is, in my mind, quite terrible. You need to start doing something there because there's a lot of opportunity.
That's great. And it'll be good to go back to the question that you posed to Andy Dieter before we started the poll around actual container efficiency, right? Andy, would you like to comment a little around that?
I don't remember the question.
What can we do to make containers more efficient, right? HPA, those kind of things.
Yeah, I mean, there's a lot of tools out there that can help these days with analyzing your usage, dynamically adjusting it. There's, some open source out there. So there's the vertical pod autoscaler and Goldilocks, which works with the vertical pod autoscaler that can sort of show you your efficiency, help you adjust it on the fly if you want. I think what we're really seeing is this shift towards more and more tools that do automated pod right sizing. There's quite a few vendors out there doing this now. And that's kind of the future that I see, because when you're a large corporation, if you're running microservices, you might have 1,000 microservices, and going back and analyzing and readjusting every single one of those is almost impossible unless you have a really, really good FinOps practice and some folks that are actually driving that forward. Going back and optimizing those containers is it's just not happening. So that's one angle of it, is the resource requests and limits and automatically adjusting those. And then application performance itself is something that I think a lot of folks are also not amazing at, because we haven't had to be for a long time. So really getting tools in place to see how your processes are running, whether you're running microservices or a monolith, looking at, where the inefficiencies in that code base are, where the inefficiencies are in your whole stack, and trying to figure out, how to reduce that utilization. And then another thing that I don't see folks doing, this goes back to what Dieter was talking about, which is the elastic nature of cloud. A lot of folks don't horizontally scale well. So one of the things that Kubernetes is great at is horizontally scaling pods, right? And you can run 10, 15, 1,000 copies of your pod. But if you're not doing that efficiently, then you're also wasting resources. And so picking good metrics to scale on is super important. Out of the box, we all try to scale on CPU, and CPU is just not a great metric to scale on. There's way better options out there. So using tools like Keta, which is an open source autoscaler for Kubernetes, to give yourself more power around autoscaling, or even that scheduled autoscaling that you were talking about, like scaling way down at night when you're not using things. Lots of different strategies out there for autoscaling.
And if the auto scaling takes place by automatically adjusting resource and limits. How do the developers feel about that? There's a little bit of conflict there because developers are optimizing for SLAs and uptime. DevOps are optimizing for other things, and sometimes there is a conflict. How do we handle those things?
Great question. This comes back to ultimately it's a culture problem, right? Is if you don't have, that healthy culture of give and take between the two teams and the ability for someone to come in, maybe a FinOps team, and have those processes in place to say, hey, our efficiency is way too low, our cost is too high, we need to tweak here and here and here, and then having buy-in from everybody in that process. If you don't have that, then at the end of the day, you're going to run into those problems. And then just trust and safety. As platform engineers, we have to put in systems that scale automatically, but do it safely. And what's the right give and take there? So I think, the balance between, performance and cost is always, if that's the balance, right? You get one or the other, and you have to land somewhere in the middle. So.
Yeah, something that we're doing, Amelia, is we use optimization. We get started with these automated optimization approaches in like test, QA, staging, those kind of environments, right? Because one thing that we did notice is that the engineer has a production configuration for their containers, right? And they know they have a history, right, of like 6, 12, 18 months of this thing running perfectly well in production. So they use the same configuration in a test environment, right? And in the production environment, that thing is sized to take like 1,000 requests per second. And in the test environment, it takes 5 requests a week, So it is very much over provisioned, right? But the engineer is reluctant to make configuration changes because they have that track record, right, of success in the production environment. So that is one thing that we are seeing, and it can get you started, right? Then you build trust in those environments, right? And then you expand it also in a production environment on a case-by-case basis.
Yeah, that's great. That's awesome.
That's a really good point. And I think one thing that a lot of folks are also, not great at, because it is hard to do, is load testing in those staging environments. So, you're talking about getting that baseline from production, which works. But if we can predict that baseline ahead of time by load testing in staging, and also test our resilience to these automated processes in our non-production environments by having realistic load tests, that can be super helpful and give you a place to build trust that doesn't affect the end user.
Yeah, that's very true. Another thing, Andy, that you mentioned was that we are primarily talking about reducing the amount of resources to also reduce cost, right? But any automated system that you are using, it also has the ability to monitor the performance of the individual containers, right? Which are called pods in Kubernetes. And if that container does not perform as it should, maybe the workload shifts throughout the day, right? Maybe in the morning you have like a lot, and in the evening less requests, right? So any automated system also has to have the capability to monitor the performance of the underlying application and give more resources if necessary, right? And that is something that is often overlooked, right? From the FinOps perspective, we always want to reduce cost, right, as much as possible. But any system that you guys are evaluating, right, or doing a proof of concept with, right, do also test if it has the ability to give the containers more resources, if that is necessary.
Right. That's
Absolutely. Right. Yeah, no, that's a great point. When we're building out cost functionality, a lot of our customers they come to us and like, we only want the numbers to go down, and we're like, well, that's going to hurt your performance. Like we need to be able to scale these things up as well. But sometimes there are places where we have flags where you can turn off scaling up, but I would not recommend it.
Yes, exactly.
Let's talk about some practical insights of where what doesn't work? What have you seen where people have tried to optimize Kubernetes and it hasn't worked, and why hasn't it worked? So kind of the gotchas we can talk about.
Well, I mean, the easy one is if you just don't set any resource requests and limits whatsoever, and you set a static number of nodes, then you will have a fixed cost, and you're kind of treating it like a data center at that point, right? Like we just kind of best effort, run these pods on these nodes, and we never automatically scale. And that, you know, you don't get the elasticity up, you don't get the elasticity down, and performance suffers massively because you're going to start overutilizing those nodes. So that's a super easy anti-pattern that I can talk about.
Peter, have you seen anything that's worth talking about on gotchas, don't do, doesn't work, or doesn't work in certain scenarios, but does work really well in other use cases?
Yeah, when it comes to the configurations, right, that Andy talked about, you really need to know what you're doing. It is easy to misconfigure this thing and build, so to say, race conditions, right, that go down in a death spiral, right, where this thing becomes, the containerized system becomes unstable and it doesn't perform at all, right? When you look at those things, what is often overlooked is data transfer as well, right? Because it depends how the containers talk to each other, right? They need to talk to the control plane, and they possibly talk to each other as well, right? And it's easy for an engineer to misconfigure this, where the data transfer is so massive that it actually exceeds what the virtual machine is capable of doing, right? And it's sort of like this is a noisy neighbor effect, right? That you didn't do anything, everything is like normal for you, right? But you get these bursts of data transfer from other containers that can impact your application. So it is important to be really aware of these things and knowledgeable, right? You really need to know how to configure this properly.
Yeah, absolutely. There's a lot of different fun ways to break, you know, a container that way. But another thing that comes to mind that I sort of alluded to earlier is horizontally and vertically scaling on the same metric. So one thing that it gets a little technical, but when you are horizontally scaling a pod based on CPU utilization, if you say, I want 80% of my, you know, one core that I've allocated to this pod for my target for my horizontal pod autoscaler, it's always going to run at 80% of one core, assuming you're not at your max on the HPA. And so your metrics will be skewed. You'll look back at the history of this pod and you will say, oh, it's only using 800 millicores at any given time. Let's reduce the amount of CPU it needs because we're giving it a full core. Well, that's artificially created by the fact that you're horizontally auto-scaling on that CPU metric. So being cognizant of the interactions of all of the tools that you're using to scale your pods and all the different configurations you have is super important. And it's not easy because Kubernetes is a super complex environment, but it's very important to have somebody who can, you know, recognize all of that.
Andy, you've talked a couple of times about, well, that's a data center approach versus a cloud approach. So in the data center world, optimization, one of the optimization techniques is over provisioning. How do we apply that in the cloud world?
We don't. I mean, it's not typically something that we do, right? We've used some over provisioning techniques in order to, you know, sort of reduce the cold start time or the scale up time for different applications. But in most cases, there are better ways to scale faster than to just over provision at the start. The cloud is extremely elastic. Utilize it as best you can. And, you know, I've seen very few cases where over provisioning is truly useful. Intentionally over provisioning, shall we say.
What about if the cloud usage, like we talk about cloud being, you know, virtual machines, but if we were utilizing the public clouds for bare metal, and then applying some of those virtual machine over provisioning techniques on the bare metal.
It's definitely something you could do. I think I know some people who might be doing that right now.
I haven't seen it before. That's why I'm talking about it, because
Yes.
it's a technique, it's a capability that is probably particularly good for stateful workloads. But just it is another approach that's not common at this point in time. So.
Yeah.
I mean, one thing that I have seen is that when you do horizontal scaling, right, you basically need to choose another virtual machine on which you start spawning your containers, right? And that decision can take into account preemptible compute options on the cloud provider side, things like AWS Spot or just preemptible virtual machines on GCP and so forth, right? And I've seen that sometimes this preemptible compute can be extremely cheap. Now they can take it away from you, right? But that's fine because the containers are more ephemeral in nature anyways, right? If you write your container and you have to run 24/7, and that is a mandate, you cannot possibly be evicted and spawn the container again. You're not doing containers right? So if you, in that choice, which virtual machine to pick next, right? If you can also look at the history of, which containers you want to spawn on that new virtual machine, right? And if you can look at the history of those containers and see like, okay, those are containers that are relatively short-lived, right? And then you can take advantage of that very cheap preemptible compute. I have seen running on virtual machines that are like 4x or 8x larger than is really needed, but they are cheaper than an on-demand instance that would be an exact fit, right? So I have seen that happening and that being done successfully.
That's really interesting. Yeah.
Yeah, that's a good point. If you're running an EKS or AKS now, Carpenter does this for you and allows you to very intelligently do that. And then there's interesting combinations of techniques where, I know that the Platform 9 folks are working on integrating Carpenter and EMP together so that you can do that over provisioning as well as intelligently selecting your node sizes and kind of use a combination of approaches where it's appropriate. And Carpenter also gives you that flexibility to say, and Kubernetes to say, like, all of these can run on preemptible instances or spot instances. And so kind of picking and choosing where the different approaches works is a smart thing to do.
Now, Carpenter is an open source tool, right?
Yes.
And I'm not super sure, but I believe it does not have the ability to choose for you whether you are running on preemptible or on demand, right? You need to sort of communicate it to Carpenter that these containers can run on preemptible.
Yes. Yeah, you would have to, if you want to, explicitly choose between them, you can. It will do things such as if the spot market is saturated in AWS, it will allow you to run an on-demand instance instead. But it will not choose which pods can run, where, whether they can run on spot or not. That's definitely beyond its capabilities at the moment.
Yeah.
Interesting idea, though.
No, there's solutions out there, right, that do exactly that look at the container history, right? And which isn't easy for an automated system because if the container only lives for a few minutes or an hour or so, right, it has to be able to re-identify that container with a historic container, right? And do the mapping so to be able to tell like, oh yeah, this container is fairly ephemeral. I can run it on one of those preemptible compute virtual machines, right? But yes, that is I think one of the shortcomings of Carpenter. And the overall, how do you feel about the configurability of Carpenter when it comes to working with a vertical scaler? Is in your experience, Andy, is that something that is easy done with Carpenter in some vertical scalar software, or are there challenges where we get race conditions that make this cluster go ballistic?
I can see how that would happen. In my experience with vertical pod autoscaler, and I'm trying to think of a couple other solutions as well. I haven't run into that issue because typically Carpenter comes in at the, the pod has been created but not scheduled yet layer. And so if you're using a mutating emission webhook to do the modification of the resources, then that's done before you get to it needing to be scheduled. Where I will see interesting things is in newer versions of Kubernetes where we have the ability to change resource requests on the fly in already running pods. And that's going to introduce some really interesting scenarios that I can't predict yet.
Yeah, very good.
So interestingly, we've spent a lot of time on the technologies and techniques and things like that, which is at the core of what this is. But fundamentally, the FinOps practice and the FinOps foundation framework, that's only a small piece of the whole framework, really, if you think about it. There's a lot of components and there's a lot of human element. Maybe, Dieter, you can talk a little bit about sort of the organizational structure components that need to be considered, and the different domains and capabilities within the foundation framework.
Yeah, I mean, containers is just one of the things that we need to optimize, right? Really, what the goal of FinOps is to make optimization one of the dimensions that the engineers need to work on, right? And bring that to the forefront of everyone's thinking, right? So, for example, if you have a production outage because something was misconfigured and wasn't allowed to go live, then that person should not be punished, right? They did something incorrectly, and the culture needs to back this up, right? So the CTO needs to say like, well, it was misconfigured, right? And this is why the government's framework did not permit it to proceed. And we need to look at it from that perspective. But when it comes to FinOps, in general, collaboration is key, right? It's the engine of FinOps. To talk to finance, talk to engineers, right? And make sure that you set goals and you measure, right? Because things that you don't measure don't get optimized, don't improve, right? And that is what you want. You want stuff to improve.
Yeah. Andy, you with Fairwinds are out talking to a lot of companies, helping them optimize. Based on what Dieter said, are you seeing that that piece of it is a challenge, the collaboration and the cultural side of it? Or are you, what are you seeing out there?
I would say most developers are not against running their applications more efficiently. So they're open to it. I think where we see challenges is where it's not prioritized on top of building new features, right? And so it's really that prioritization piece of it where the struggle comes in, because somebody will say, we want to run more efficiently, or even it'll come from the bottom up, and the development team or the platform team will say, hey, we can run more efficiently. But then we are, our backlogs are stacked with feature development and we don't have time to do that work. And that's where that collaboration piece that Dieter was talking about comes in. When you have buy-in from both the top and the bottom, and the finance department all working together to say, this is a priority for us. This is where it fits into the queue. Let's take some time to do this. It's the same as working on tech debt. It's the same as, improving your infrastructure. It's the same problem. It's just that we haven't been thinking about it that way. And that's one of the things I love about, when I also did the FinOps practitioner exam and went through the whole course. And, I liked the way that it was structured, in that it's really about that collaboration, finding the right people, getting them together, and then having buy-in from both, top and bottom.
Awesome.
Yeah, Amelia, I think fundamentally, right, when you look at the psychology, I see three things why people don't do what needs to happen, right? One is they don't know how. The other one is they are not motivated, right? And the third one is someone else told them not to, right? That's really what it is, right? And the not knowing how, you can overcome that with training, right? The motivation, you can overcome that with going to leadership and working with leadership on making this part of performance reviews, right? And that will also fix they're not giving time to work on those things, right? What we do is there's multiple business units within Roku, right? And each business unit is siloed intentionally, right? So that they can make decisions fast within that silo. But what we ask them is to either make this a part of every sprint, like let's say you dedicate 10% of every sprint to doing some kind of optimization, right? Or other business units prefer that, maybe once a quarter, they have like 1 or 2 sprints that are just focused on optimizations. And so those are the 2 things on how to get started, right? But again, it comes with leadership buy-in, right? And leadership may not always see cost as an issue, right? When you look at overall spend, headcount is about half of the company's revenue, at least we hope. And then you have things like, physical offices and operations and sales and marketing and things like that. So by the time you get to the cloud cost, it becomes a very small slice on an overall large pie, right? And leadership may not see this as a problem, at least initially. What I have seen happen a couple times is that you get to a tipping point where a CFO comes and says like, hey, our cloud spend is growing faster than revenue, right? And then you have a problem, right? And the way to overcome that is to find some kind of business KPI, right? It could be cost per streaming hour, it could be cost per ticket sold, or cost per tax return or something like that, right? And determine what is a reasonable KPI to track, right? And what is a reasonable measure that you want to stay flat at, and then fund any new development through optimizations, right? And the way to do that is to have sort of like a waste dashboard, right? With dollar numbers and people's names, technology leaders' names, right? And sort that by the highest dollar number on top. And this way you can gamify that experience a little bit to entice people to do these optimizations. And you give them a choice, right? Okay, I want to launch these 5 features. They will introduce 100,000 a month more. And oh, look at that. I have 150,000 of optimizations that I can do. And so I can fund the new features through optimizations.
I love that. I love that. It's like you save your money. It's like talking to your kids. Save your money and you can buy the bike or whatever it is you want.
Right.
The toys and lollies.
Exactly.
Love it.
Yeah.
That's awesome.
Yeah.
All right.
I particularly like the first part of that. It's something that we've done a lot is, talking about sort of our product side, because we have our services arm that runs Kubernetes for folks. We're talking to them about their costs, but we also have a product that we make. And so we're doing our own FinOps practice internally. And really where it started was we don't know how much it costs to onboard a new customer, right? It wasn't about optimization. It wasn't about spending too much. Our cloud spend is actually pretty low for an organization of our size. We're fine with that. But what we didn't know was if we onboard this next huge customer, what's that going to cost us? And what's our actual like per customer cost? And so it was really much more about the understanding cost piece and the visibility of it, not the optimization. I know this webinar is about optimization, but I think the key part of FinOps is the first thing is always about visibility and seeing your cost, not just jumping straight into optimization, because we have to make informed decisions about when, where, and why we optimize.
Absolutely.
So we've got 1 minute left, and I noticed that we have a question that goes, going back a little bit from Jonathan. Thanks for your question, Jonathan. Your observation is that Kubernetes scale out, HPA, Keter, etc., works great. That's awesome. Consolidation after the load spike, much less well.
I can address that. So by default, the HPA is designed to scale down much slower than it scales up. and that's intentional for, you know, reliability and safety reasons, you can change that in the newer versions of the HPA. All of your various parameters for how quickly you scale up and down are all tunable in auto scaling v2. So that's one part of that. The second is when you consolidate your pods, you also have to consolidate your nodes. And if you're using cluster autoscaler, which was the you know, most common way to do this previously, cluster autoscaler is terrible at consolidation. Like, it's really awful at it. So switching to a more intelligent cluster autoscaler will help your nodes consolidate down faster as well. So whether you're using Carpenter or one of the off-the-shelf solutions out there like Spot, or I know there's a couple I'm probably missing, but those will help you scale down your cluster size, which is really where cost comes from, right? You don't save money by scaling down the number of pods if you still have the same number of nodes. You have to scale down your nodes as well. So yeah, a couple things to look at there if you haven't already.
And it's really important that this autoscaler is intelligent, right? Because we had a case where when a pod gets terminated, it sort of creates a gap, right? Imagine you have like a Tetris game, right? And you take one of the stones out. And it has to have some intelligence about what is going to be scheduled next. Will it fit in that gap? Or do I need a new virtual machine, right? And that is the tricky part, that it may just create this sort of fragmented environment, right? Where the next pod might be a little bit too large to fit, right? And doing that intelligently is key, right? And there are some solutions out there. Platform 9 is one of them that has the ability to move pods between virtual machines, right? They use vMotion essentially. And what vMotion does is it copies the memory of the pod from one virtual machine to the other virtual machine, and then moving the pod itself is just a few milliseconds, right? So it's an almost imperceivable interruption or just slowdown, right? So there are technologies out there that are smart and can do this, right? And it's important to be knowledgeable around those and be able to configure them correctly as well.
Good. Well, we're out of time. I want to thank you, Dieter and Andy, for your time. Dieter, how can people get hold of you if they have any more questions?
Oh, they can just go to my website. I will put it in chat here. Now, I don't have a security certificate, so don't be alarmed. You have to pay for those, right? So my website is free. So if you just want to reach out to me, best way is probably on LinkedIn. Just look for matzion.com, and there's all my information.
Excellent. And Andy, if anyone has any questions for you, how can they reach out to you?
Let's see, CNCF Slack, Kubernetes Slack, LinkedIn, and we also have a community Slack for our open source at Fairwinds that you can find on any of our GitHub repos. I am usually Suderman Jr., Suderman Jr., or Andy Suderman in any of those places.
Awesome. Great. Fantastic. Thank you for your time. And if anyone has any questions about Platform 9 or our technology, you can go to elasticmachinepool.com, or you can go to platform9.com as well. Thank you, everybody. We had a great time. Have a great day.
Thanks,
Thank you, everyone. You guys take care. Bye.